have finished LC synthesis. Now I am taking you to RC synthesis properties. As we already understood, the simplest properties are two. RC, LC, germ axis near. It's not on germ axis but on real axis. So the pole of Z function is near to the origin, and then so what is near to the origin? RC means nearest to the origin is pole. When I say nearest to the origin, please understand it can be also at the origin. So do you see, look at this property. Poles and zeros are on left hand side. The nearest to the origin is pole. Second, for y of s, that means reverse. When you take reverse, it should be 0. First form 1 is for z of s k0 by s, k1 s plus sigma, k infinity. When it comes to faster form 2, please remember it is y of s by s. You know why? If you take y of s, you will get inductance. If you take y of s by s, you will get resistor. So to avoid the inductor in RC synthesis, admittance should be divided with s. Are you able to understand? Once again, see, look at your z of s here. Something by s means what? In impedance, something by s means capacitor. Capacitor is valid. This is a constant. Resistor is valid. But if we take y of s, k0 of s by s, it's not valid. Because admittance 1 by ls. So whenever you have something by s in admittance, that is talking about inductor, but we want to have everything only R and C. To avoid inductance entering into this picture, we better divide with by s. That's very interesting. Then k0 is how much? Z of s into s, s equal to 0. What is k1? Z of s into s plus sigma, s equal to minus sigma. What is k infinity? Z of s as s tends to infinity. S tends to infinity means 1 by s tends to. Whenever s is tending to infinity, what is 1 by s tends to? 0. Like that, you can cross multiply them and calculate the respective value, identify the component. This is about faster form 1 and faster form 2. Now look at the problem number 5. Obtain fast form 1 for s plus 1 by s plus 2. What is this function? The moment you see this function, see all roots on sigma. Roots are on the real axis. When the roots are on the real axis, what's going to happen? When the roots are on the real axis, please remember this should be either RL function or RC function. And if this is Z of s, of course, definitely nearest to the origin or at the origin is a pole. Therefore, it has to be RC function. Then, as I told you, fast form 1, assume that k0 by s, k1 by s plus 2 plus k infinity. Then calculate k0 and k1 and k infinity. Check the series combinations and find out each component value. And once you find the component value, you put here 2f, 1 by 4f. So this is called series combination of parallel branches. Fast form 1. That's problem 5. Next problem. Obtain z of s for the above function. That means what? This is 1 by 2s, 1 by 2s, 1 by 4m. So parallel combination of 1 by 2s and 1 by 4 plus 1 by 2s will give you the function as same. So you are very confident now what you have done has been retrieved. Whatever you have done earlier, the synthesis, you got the function. Therefore, for the function you got the circuit, for the circuit you got the same function. Therefore, you are doubly sure about your answer, right? This is just to confirm you and give you the confidence. I am doing the problem in the reverse order also. Problem 7. Same function, go for faster form 2. If the given one is z of s here, what will be y of s? Y of s by s is 2s plus 2 10 s plus 1. So what will happen? If we must reverse it. When you reverse it, what will happen? And that too, y of s is equal to this by this. Now if you multiply by s, what will happen? SS will cancel. And you will get the function. Okay. This s will be cancelled here. So when this cancel, if you calculate the series combinations, you will get a circuit in this form. Infinity, 10, 1 by 10 here, this also 1 by 10. This is parallel. That's why fast form 2 is said series combination of parallel branches. Series combination of parallel branches. And I also told you one thing, in any parallel branch, short circuit is not allowed. Similarly, in any serial branch, open circuit is not allowed. Open circuit series is not good because it's completely open. Short circuit in parallel is not good because it's completely short. Now let me take you for the same. For the circuit whatever you achieved, why don't you go for Z of s? Obtain Z of s for the above problem. So 10, 1 by 10, 1 by 10, infinity. Calculate impedance or admittance, whatever. Normally people like parallel circuit means admittance, doesn't matter. After all, it's a very small one, you can directly do it. It's a parallel combination of 10 plus 10 by s, parallel 10 by s. See that? The answer is coming. So when you got the same answer, that means you are confident about cross-checking the answer. So most of the problems what I did is, I have done the realization and I have done the cross-check. Because synthesis you are studying only as one chapter, so I am doing both reverse way also. Analysis we have a big subject. Synthesis is most of the universities, it is elective. But in GATE exam you have a small introduction. But remember, in IES big subject is there, separate subject is there on synthesis. Right. Now having done RC, now let me take you to RL. RL means all these components should have only RL. No other component should come. The pole of y of s function nearest to the origin and on the real axis. Please remember, pole is nearest to the origin. But of what? Pole of y of s. As I told you already, the z of RC properties is same as y of RL. In z of RC, if the pole is at origin, in YRL, pole is also origin. Then functions, they have to have nearest is, if you take z of s, it will be 0. First form 1, z of s by s. This is very interesting, one should remember very carefully. Come on here. For example, z of s by s, k naught by s, what will happen? Suppose if you don't take s, if you simply take k by s, what will happen? K naught by s, if you take without s in the z, z is equal to k by s. That means it is a capacitor. To avoid the capacitor, I am dividing by s. Then what happens? SS will cancel. You will get a resistor there. So wherever there is a possibility of getting another component other than the component that we expected, go for dividing with s. That's a very simple, customary to remember. You can easily get it. You don't need to mug up here. You can just try. As you do it, you will understand. For example, if it is a RC circuit, L should not come. RL circuit, C should not come. To avoid that, what to do? Divide with S. So that's what we are doing. Y of S here you see. In the fast form 2 is always Y of S. Please remember. Fast form 1 is always for Z. Fast form 2 is always for Y. So y is equal to k naught by s. What is it actually? Which component is this? For example, y naught is equal to 1 by L naught s. So inductor is coming. So therefore, something by s is accepted. Another important thing you should remember is this right hand side we don't want to change. We want to stick on the same idea whether it is RC or RL. In RC also we took the same function. In RL also we took the same function. In impedance we took the same function. In admittance we took the same function. Only possibility is to avoid the unwanted component, you must learn where to divide. Indirectly speaking, divide with yes wherever is not possible, not to have the component. But directly telling, in RC, divide y with s. In RL, divide z with yes. What interesting thing. So simple. So keep this in mind and then let's go for problems. Now I am continuing my number of the problems, that is ninth problem. Obtain first form 1 for z of s 10 into s plus 1 by s into s plus 2. So this is given, it's he himself said it is z. Is it true that it is really z? Because you must understand immediately, is it if the nearest to the origin is pole here. If the nearest to the origin is a pole, you cannot achieve this. Therefore, by s is good. When you take by s, this problem is solved. And you can immediately do this. You can get the circuit. Similarly, for that circuit, first form 1, divide by s, solve for k1, k0 and k infinity, then the circuit is this. This is called RL circuit. This is RL, this is here. Now as usual, as you know, I am going to take the circuit in the 11th problem. Obtain z of s for the above network. That means what? The network is, whatever network we achieve, we will get in the reverse order. And when if the same z of s is coming, you are happy. Look at that. You really got the same thing. So you have to get the same answer what you have really taken. Next, obtain first form 2 for z of s. This is z of s taken. This is first form 2 is for what? Is for admittance. Then calculate k0, calculate k1, calculate. Please remember, when you take admittance, s plus 1 came up, s plus 2 came down. That's why root is s plus 2 here. Z of s is given, convert into y of s and solve. This is the meaning. You will get these values. Then next problem would be what? Problem number 13. Same circuit, calculate z of s. This means what? Ls plus R. Ls. Let us say L0 parallel L1s plus R. If you calculate, you will get the same function. So I don't need to repeat every function again. It's only for your confidence and your calculation I am doing this job. So let's go for 14. Now I am turning myself into Cauchy forms. Obtain Cauchy form 1 for the z of s, s cube plus 2s by s square plus 1. Please understand, faster form is factorial form by factors, whereas Cauchy form is by polynomial. That's why the factors I have converted into polynomials. This is also called continued fraction expansion. This fraction is continuously divided. You look at here, s cube plus 2s is divided with s squared plus 2. Then what happens here? Put with s, s cube plus s. S cube cancel, s becomes s here. Bring this one here, then divide with s. S square cancel, 1 comes here. Then put this s here, s comes here, totally 0. The first element is inductor, second element is capacitor, third element is inductor. How do you know that? You know this by saying, because z by s, that is, this is s here. The first element has to be L, because in impedance s is Ls. Then why this became, this is also s now, why it became C2? Because you are dividing the denominator with numerator. That means reverse it. So reverse means 1 by s. So this is called admittance actually. This is impedance, admittance, impedance. Wherever there is s as impedance, we call inductor. Wherever admittance, that s means capacitor. That's why L is equal to 1, C equal to 1, L is equal to 1. That's going to be our form. So 1 plus 1 plus 1. If you make that circuit, that is the simple circuit, ladder network. It's a ladder network. You can put ladder means one after the other. Okay. Then obtain Kaur form 2 for the same. See, look at here. Same means one is ascending order, second is descending order. Please see, in the first form 1 is descending power. Normally we always have a habit of higher to lower. Higher to lower means descending. Whereas here I am going ascending. When I go for ascending, what happens? This has to be divided with this. And do that. 1 is here, 2s. 2s into 1, 2s. 2s into s square, 2s cube. What do you get here? Minus. Whenever you get minus, skip there. Skip that particular step. Okay. Now continue the solution. Instead of that, I am taking y of s. Because that has given me negatives now. As I said, we are all talking about positive real functions. Positive real function will never achieve negative values. In fact, no component is a negative value. So no negative should occur here. So when z of s is creating a negative, then better go for y of s. Then I have taken the reverse order. Numerator, denominator became numerator, numerator became denominator. You see, 1 by 2s, then 4 by s, then 1 by 2s, 0. So when you look at this, when you say by s, we can say this is C1, L2, C2. So C1 is here, L2 is here, C3 is here. These are the values that we have achieved. So with that, we got the circuit. This is called ladder because first element, second element, third element. First element, second element, third element. Because in admittance, what exactly happens is inductor becomes 1 by L2s. 1 by L2s is 4 by s, therefore s cancel. L2 is 1 by 4. This is 1 by 2 into s. 1 by 2 into, okay, 1 by 2s, 2s cancel and become 1 here. So this is how you can achieve your component values. That's called Kaur form. So Kaur form is a very simple thing than the faster form. Because in the Kaur form, it is a polynomial is put into. What we have taken into consideration is polynomial. Let's go to 16th question. Obtain RC faster form, Kaur form 1. Then put it into this. Again you got a negative. Wherever you got a negative, skip it. Then what's the next option? Go for admittance. Instead of doing impedance, go for admittance and you will get your, see, S by 10, see here, 10 resistor, S by 10 capacitor. This is the circuit. You can cross check the answers. You see, this is a ladder network, whereas this is matched. So therefore, what is matching you have to see here. This component is not matching. So best component is 10 here, then and then matching. So cross check which element comes first, because first element is missing. Wherever you have seen the skipping, you please eliminate that component. First element is missing, so automatically second comes with the capacitor. Cross check which one is matching and why I should not start this in a series arm but as a parallel arm. Next, obtain RL Kaur form for Z of S is this way. Very simply convert that into polynomial. As I said, Kaur form 1 is for descending. So descending means what? S square plus 2s, s plus 1. You divide with this, with that one, again put here, 1 comes here, then 1 comes down here, put that s here, 0. So 1, 1, 1, 1, 1, 1. So this is called Kaur forms here. Good. So very simple, the standard procedure, don't need to repeat again and again. Next, this is something strange. I have changed in problem. Obtain driving point impedance for the circuit shown. Actually speaking, this circuit is, it's neither RC nor RL. This is called RLC circuit. So you need to calculate driving point impedance. Driving point means what? Here or here. Z11 you have to calculate. It is just like two-port parameters what we did. Put I20, Z11, V1 by I1. That way you can calculate. Or you just see here and say these two are in, when I20 this is nothing here. These two are in series. Then that is in parallel here and plus. See there. I am saying here Z11, I20, Z11 is 1 by S into S plus 1, 1 by S. Because this is 1 plus S into S plus 1, S into S plus 1 by S into. So it is just like saying Z1, Z2 by Z1 plus Z2. So 1 is added. If you add that, you will get this function. This is driving point impedance. If you want output side, put I10 and get it. Will you please compare these two? Literally, these two are same. Why the Z11 is equal to Z22? The answer is simple. Because the circuit, if you look at, it is a symmetrical circuit. In a symmetrical circuit, whether you see the impedance here or you see the impedance here, they both are same. So this is a small variety for saying it's not, you are not simply designing or realizing circuits, but you're just taking impedance. Question number 19. Calculate RC in the circuit shown. Z of S is given, circuit is given, and the values are also given as options A, B, C, D. Now look at here very simply. Be blind and simply calculate. Say this is R1, C1, R2, C2, R3. So parallel combination of this in series with this and entire parallel here, finally series. Achieve the impedance function and compare the given answer and calculate the values. So what values I have to get? The value of R, value of C. Shall we do that? I have calculated Z of S here. I will realize the function now. Whatever the function and circuit he gave, I will try to achieve now. And how do I know is a faster form 1? Basically, Kaur form 1 is descending order. So descending order is there. He already gave Z of S in the descending. Please remember, Kaur form 1 and Kaur form 2 both are for Z of S. But only difference is Z of S in the descending order is Kaur form 1. Z of S in the ascending order is Kaur form 2. Whereas fast forms are not like that. Fast form 1 is for impedance. Fast form 2 is for admittance. Okay. Now take the function. Forget about the circuit. What he gave, you achieve a circuit. By achieving circuit, you can identify the values there. You can simply say what should be the values of R and C. For this one guarantee I can give you, this is a ladder network. Therefore, you can achieve whatever the components are absent or the values are not given, you can identify. So this is also one of the ways that he is asking a problems in networks function. So that's why I titled this as not simply synthesis. It is also network functions. Let's go to 20. Question number 20. S into S plus 2 by S plus 1 into S plus J plus 1, S plus J minus 1 be a function. In order to make N of S as a rational function, it is essential to add 0 at origin, 0 at infinity, pole at origin, pole at infinity. So what exactly I mean is, he has given, this is good, S into S plus 1. These are complex numbers. So what I should add to make it as rational? Let's see the problem. To be rational, poles add 0 at the infinity because pole is already there. Look at here. The pole extra is already there. See? S equal to 0, then comes here, pole comes, then 0 comes, then pole comes. So you add pole at origin so that S and S will cancel. So because there is a 0 at origin, if you can multiply with pole at origin, you can simply achieve that rational function. Rational function means what? No zeros and no functions poles there. Option is B. From the given below functions, which function indicate RC impedance function? What a nice idea. He's cross-checking you whether you know the properties or not. So what is RC first of all? RC means it must be on real axis. Secondly, the nearest to the origin should be pole. The nearest to the origin should be pole. So look at here, S into S plus 3, nearest to the 0 here. Here nearest to the pole here. Then C, pole is nearest here. And then pole is nearest here. And what is the wrong in it actually? The answer is very clearly S plus 2, S plus 4, S plus 1, S plus. See, when you look at this, S plus 1 is the nearest to the origin. Nearest to the origin is pole. But here also nearest to origin, now what is the wrong in it? Why C is wrong? C is wrong because S square plus 1 means it is talking about roots on j omega. Roots on j omega means it gives LC function. So C gives LC function, not RC. Then here S plus 1, this is also okay. Here this is also okay, but this A is wrong because you have nearest to the origin is 0. So A is wrong because nearest to the origin is 0. C is wrong because it is talking about j omega terms and where you have what you call LC. So A and C are wrong. Then why B is wrong? You should work with me. Look at here. First is a pole. That's what we wanted. But unfortunately, second is also pole. If two poles are there, what will happen? There will be breakaway point. If the breakaway point comes, what did I say? It will break and go somewhere. If it breaks and goes and enter into the right hand side, the system becomes unstable. And if a system is unstable, such a systems we never synthesize. We need to synthesize or design a circuit which is unconditionally stable. Therefore, I already told you, you should not have poles consecutive. Indirectly, I told you, poles and zeros must be alternating. So what is happening is side by side is there, consecuting is there. That's why B is wrong. Otherwise, B is also correct. Whereas here, look at the D. Pole came first, then 0, then pole, then 0. So nearest to the origin is a pole. And they're alternating here. Therefore, my option is, the option to this question is D. D is the option because a pole should be nearest to the origin and alternatively located. So the possibility is D. Next, 22. Y of S is equal to S square plus 25S plus 1 divided by S square plus 4S plus 3. Then Y of S is RL network. 2. Poles and zeros on the real axis. Alternative. C. Third one. Lowest critical frequency is pole. Y of 0 is 1 by 3. So you have 1, 2, 3 are true here. 2 and 4 are true there. 1 and 3 are true. 1, 2, 3, 4 are true. So let me talk to you one by one. First, you convert them into factors. Once you convert them into factors, the nearest to the origin, actually, if it is Z of S, nearest to the origin is 0. But this is Y of S, so it should be a pole. So nearest origin to be a pole, let us see how. And poles and zeros, unless you really calculate the roots here, you cannot say whether they are alternating or not. So let me take you for what you call roots here. S plus 0.5, S plus 2, S and S plus 3. That's what means what? The nearest to the origin is a 0. 0 is nearest to the origin and poles and zeros are alternating located. So it is RLC network, RL network with S equal to 0. You substitute, you will get 1 by 3. Therefore, what is the option here? Option is B. B means what? What are the things satisfied here? 2 is satisfied because they are alternating. One is satisfied because the 0 at origin, okay. Then y of 0 is here, because if there is a 0 at origin, there can't be pole at origin. So this is missing. Therefore 1, 2 and 4, that's why the option is B. Let me go to 23. Question number 23. Match the following: RC, LC, RLC, RL. Then list 2, negative real, imaginary, either real or complex. What are the options that we can have? RC, negative real axis, RL also negative real axis. So you can have A is 1, very good. 1 here. Oh, A is 1 here also. So you have all the 3 options to you. B, LC, the roots are completely j-omega axis. So B is 2. Where is B is 2? B is 2 here. Nowhere. So one thing I can comfortably say, by looking at this, I can say the option is A. So matching you should really enjoy. By making one point, you can eliminate. I always go by elimination of the process, because in MCQ, that means multiple choice questions, most of the time elimination works out well, particularly in matching. Look at here. If I look at RC and RL, RC is negative axis, so A has to be 1. A is 1. A is 1 in 3 cases, so it's not working out. Then I turn myself to B and imaginary here. So that is working out only in one case. So I enjoyed it and finally said simply B. Therefore option is A. With one simple answer, I am ruling out them all and then finalizing answer. What a simple thing. That type of techniques you must really adopt to make it very, very fast. So finally option is A. Next, matching. Match the following: list cover form 1, fast form 1. B, cover form 2, fast form 2. What is the list 2? L is in series, C is in parallel. C is in series, L is in parallel. Series combination of L and C in parallel. Parallel combination of L and C. Very simple. Just now I told you. Forget about ABCDs. First let us enjoy these options. Series combination of parallel. That's fast form 1. Parallel combination of LC in series. Parallel combination of L and C in series. This is fast form 2. So fast form 1 is 3. That means A is 3 for B. C is 3. Where is C is 3? Oh, we have so many. Then it doesn't work out. Then 4 is, fast form 2 is D. D is 4. D is 4. Where is D4? Yeah, at least this is working out well. A seems to be correct. B seems to be correct. So you can rule out wherever there is D4, take that first. That means the answer has to be A or B. Then the next check that you can have is cover form 1. L in series and C in parallel. C is in series. Don't go that way. You better go one way, because this cover forms is always confusing and cheating. Something is missing and then it automatically next element comes. The best way you go through is C becomes 3, D becomes 4. Where is that? C becomes 3, D becomes 4. Oh, 2 is there here. You have A as well as B. Unless you settle this A1 and A and B, you can't settle. So answer is between A or B. To complete that, take the help of cover form. L is in series and C is in parallel. C in series and L in parallel. So option is A. Good. So he is really checking whether you know the properties or not. Next, question number 25. Pole and zeros of a driving point function of a network is simple and alternating on j-omega axis, then the network consists of. Once again, pole and zeros of a driving point function of a network is simple. What do you mean by simple? Simple means the root is not repeated. So far I did not tell you, that's why I am telling now. Simple means root is not repeated. And then alternative on the j-omega axis. Oh, that's good. J-omega axis is purely LC. So option has to be RC no, LC no, j-omega axis purely C. Therefore Option is straight away, without too much of struggle. Answer is C. Question number 26. This is assert and reason. Z of s is equal to k to s square plus 2s square plus 10 by s square plus 1 s square plus 6 represent LC. Is this true? Seems to be true. Poles and zeros are alternately located on the geometric axis. So what are the options that you can have? Both A and R are true. Yeah, seems to be true because this is a pole is coming first, then 0, then pole, then 0. All are on geometric axis, that's good. Poles and zeros alternating on geometric axis, that is also true. So the option is either A or B because both are true. All that you need to say is A is true, R is false. Both are true is the best thing. So this is the answer we have. Option is A. He is not asking actually he should tell you one more thing to say. Reason is the reason for answer A. Assert. Reason is the reason for assert. He has to say, but he didn't say. So enjoy the simple thing. Both are true. Finish the answer. 27. The necessary condition and sufficient condition for a rational function of S, T of S to be a driving point impedance of a network's function that all the poles and zeros should be. GATE 1991, 2 marks is given for a small thing. Once again I am reading the question. The necessary condition and sufficient condition for a rational function of S is T of S to be driving point of RC network that all the poles and zeros should be simple and lie on the negative real axis, complex and lie on the negative real axis, complex and lie on the left hand side, simple and lie on the positive axis. According to the properties, what do you think? Option is definitely A. Why it is A? Look at here. They must lie on the negative side. They must be simple. Then, whereas the second one is wrong because he said complex. Complex is not possible for RC. C is also wrong because he said complex, not possible for RC. Complex is only possible for LC. D. Simple and lie on the positive real axis of the S plane. Simple, lie. The simple is okay. Positive real axis, that is unstable. That's not possible. So, because of complex is not possible, B and C are wrong. Positive side should not be taken. D is wrong. Therefore, I am only left with option A. Question number 28. The driving point impedance Z of S of a network has the following pole zero diagram shown in the figure. Z of S is 3 gen. Z of S you have to achieve. It's a very interesting problem. Most of the times it comes. Then people do not know whether it's coming from signals or networks or for control systems. As I've been telling, all these three subjects are similar. Now look at here, take the roots. If it is a 0, this is a 0 here, these two are poles. So take the roots. If it is poles, put it in the denominator. If it is zeros, put it in the numerator with a constant k. And put s equal to 0 equal to 3 and the k will automatically come. Very good. This also we should know at least once. Okay. Now let me show you the solution. You look at this, s plus 1, s plus s equal to minus 1 plus j1 minus 1 plus j0. If you put these two factors, then 0 means s plus 3. So k by s plus 3 into s plus 1 square plus so on. Put s is equal to 0, then what happens here? 3. K 0 plus 3, 0 plus 1. So 3 is equal to k by 3 by 2. Okay. If you say that, k becomes finally 2. So therefore in the place of k, you please substitute 2 here, 2 into s plus 3 by s square plus 1 plus this. Now let me take you back to options here. Option is B. Because instead of making the factors like separated, you can as well make this one. S square plus 2s plus 1 plus 2. So therefore s square plus 2s plus 2. That's why option is comfortably B. The whole difficulty in this is actually one should know is estimating k. So from the pole zero diagram, how to achieve the function is also one of the expected problems. Question number 30. The first and the last critical frequency of RC point function impedance must be respectively. This is GATE 2005, 1 mark, basically checking the properties. Now why I am saying GATE 2005 and all that, because some students are thinking they are not in the syllabus. You see there? It is there even in EC. Network functions is there in EC also. But only synthesis is mentioned in the EEE. Therefore, networks function and synthesis are inseparable. Therefore, I am showing you some questions given from the GATE exam is to tell you that you need to study this syllabus. Right. Now, let me back to the question. RC. Good. First thing you must listen, what is that RC? Then, impedance or admittance? Impedance. In a impedance function, the nearest to the origin is what? That's called first critical frequency, has to be a pole. Therefore, A is cancelled, D is cancelled. It must be a pole. If the first one is pole, last one cannot be pole. It has to be 0. Therefore, my option is so simply C. What are simply problems, and you are really achieving marks and do well, because this is not the total subject as subject. They are not asking. They don't go into depth because it's not a subject, only introduction. Therefore, wherever the topics are simple, please score well. Read less and get more marks. Because for RC network, pole is nearest to the origin, and when the pole is nearest to the origin, 0 has to be at the final. Therefore, option is correct. Now 31. The first and the last critical frequencies of a driving point impedance function of a passive network having two kinds of elements are a pole and 0 respectively. The above property will be satisfied by. Oh, question is so big. Once again, the first and last critical frequency of a driving point function of a passive network having two kinds of elements are pole and 0. Please understand this, very simple, just like previous question. The first is a pole and the last is a 0. Then automatically what it should be? It has to be RC network. Look at that there. RC network, you see. So from one year to another year, last question was basically which year? 2005. 2005, he gave the circuit and he is asking you to go for identify poles and zeros. First critical and last critical. And next year, 2006, he is giving the first and the last elements, asking you to identify. See, he is checking, just slightly changing the question, that's all. Properties to circuit, circuit to property, and if both is not interested, then he will give the pole 0 diagram. So all through, it's simply going around the properties, please. If you are good in properties, you are going to do well and score well. Question number 32. The driving point impedance of the following circuit is given. ZFS 0.2s by s square plus 0.s plus 2. The component values. This again I am showing you EC, electronics and communication. Because though it's not mentioned clearly in the syllabus, please see the question paper. That's why I always say, don't prepare for the exam without seeing the question paper. Understand my slogan. Syllabus will tell the width, question paper will tell the depth. So you must know both. Now I am taking along with you to understand these elements. You see, he is given, we have to get the driving point impedance of the following circuit is given. This one, the component values we have to identify. These three components you have to identify. The best simple answer is, forget about all synthesis, just say R parallel 1 by CS parallel LS. Do that and adjust here, and then you can really get the function. Come on. Or I will take you to this. 0.1 by this, y of s. You know why I am taking y of s? I hope you understood why I am taking y of s. Because whenever the circuits are in parallel, we always take y of s. When you take y of s, you get this. Because y of s is exactly reverse of the z of s. I didn't do any great thing there. I just taken this one and reversed it, y of s came. Then I have done different factors. Then what is y of s here? If you parallelly adding, see, this is CS. This is 1 by R. This is 1 by LS. So 5s here. You look at it. S by 0.2, 5s. 0.5, 10 by s. So Cs plus 1 by s, 1 by ls, identify C has to be 5. 1 by r is 0.2, 0.5. That means r is what? 2. And 1 by ls is 10 by s. Therefore, what should be L? 1 by 10. 1 by 10 is 0.5. What a beautiful and simple thought. Therefore, option is D. Look at the options given there. Question number 33. The transfer function, if the circuit shown in figure, GATE 2013 and SEC. So 0.0, see, 100 micro, 10 kilo and this. What is the transfer function? Transfer function is very simple, as I've been telling, output by input. So V naught is equal to Vi by 1 by Cs, right, plus, what says this is C1, 1 by Cs, 1 by C1s by R plus 1 by C2s into R plus 1 by C2s. So whatever is coming across this mathematics, you can simply put here. That's the question number 33. So you look at here, I am just dividing it. So transfer function is V naught by Vi. Directly you can calculate. Calculate I, multiply with this R, directly you can do it. So option is D. That's the end of it. All the best. And we have completed this total subject networks, starting from fundamentals, go through the analysis techniques. Please remember, I have divided the total subject into few things. First one, introduction is given. Second, general analysis techniques. Then third, specific analysis techniques. Fourth, I have taken to time response. Fifth, I have taken to frequency response or sinusoidal analysis. Sixth, I have taken to 2 ports. And in the 2 ports, of course, we have gone for synthesis also. So these are the very simple things. In any subject, what is the introduction to the subject? What are the simplification techniques? Then ultimately you have only 2 things, time response and frequency response. Of course, in networks we have a special one called 2-port analysis. So instead of creating a separate topic for synthesis, I have brought the same thing. Synthesis also has one of the topics of 2 ports, because we are talking about driving point functions and impedance functions, transfer functions. There's nothing but Z11, Z12, all that. So this is how we finish this subject.